Last class we discussed about exercises from unit 9. That means in the unit 8 and 9 we discussed about motion and force. There are different types of motion we discussed in the unit motion: uniform, non-uniform, speed, distance, velocity, acceleration, etc. Then next, force. Actually, what is the work force do? It actually causes the motion. Force is the cause of motion. But it's actually force is the cause of motion. That means to produce motion, force is required. Now we are going to discuss about some other force, that is gravitational force. Gravitational force, otherwise gravitational force or gravitation. We know when we throw a stone upward, it goes to a certain height. When we throw, suppose a stone is throwing up, this stone goes up to a certain height, then it falls down. We know to move this stone to up, we exerted a force. Because of that force that moves to a certain height, then why did the stone falls down? That means they are exerting some force to come it down. And also, when we observe, similarly, moon. See, moon goes around Earth. Moon goes around the Earth. Why? Why that moon is going around the Earth? And also when we consider all planets moves around the sun. Newton put forward an idea that are due to some force. That means when the stone falls down to the earth, because earth exerted certain force on this stone. Similarly, this moon that also goes around the earth. In the case of planets that moves around the sun, here are, that means sun exerting some force so that the planets moves around the sun. Similarly, earth exerting such force, because of that moon moves around earth. See, that type of force, and it is called gravitational force, and that type of force is a gravitational force. Let us discuss about, suppose a stone tied to a string, and if this stone is reeled, that means it moves in a circular form. This stone moves in a circular form, and to the motion of this stone, there is a force, and that force which keep this stone in this circular path. That means this stone is moving around a circular path, and to move this circular path, this stone should get a force, and that force is called which force? Centripetal force. That means to move this stone around in a circular path, some force acting on this stone, and its direction is towards the center of the circular path, and it is called centripetal force. Suppose if this stone lost this, force, this stone moves. Suppose here the stone lost this force, then the stone moves along the tangent, along this straight path. That means if we draw a tangent at this point, then the path of the stone is along this. Suppose if the stone lost here this force, then this is the tangent at this point, and the path of the stone is in this line. Tangent means it is a line that meets at only one point on the circle. Tangent is a straight line that meets only one point on the circle. Here, this moves in this path. Suppose if this stone lost here, then if the stone lost the centripetal force, then this will move in this direction, this tangential point. In the same manner, we know moon is moving around the earth, and this moon and earth, there is a force. That means earth exerting a force on the moon, and that force keeps the moon in its circular path around the earth. And that force is called what? Here that force is towards the center, so it is called centripetal force. And how that centripetal force is getting? It is due to the gravitational force, otherwise due to gravitation. That means a force exerted by the earth. Force exerted by the earth is that keeps the moon in the circular path around. Similarly, force exerted by the sun keeps the planets around. Force exerted by sun keeps the planet around the sun. Now see, by these observations, that is from the laws which derived by Kepler, that is Kepler derived planetary, that is motion of planets, three laws around about the movements of planets, and they are called Kepler's laws of planetary motion. Kepler's laws of planetary motion. That means the first law says that all planets moves around the sun in an elliptical orbit. That means all planets moves around the sun in an elliptical orbit. That means in this way. A long circle is the ellipse in an elliptical orbit, with the sun on off its foci. With the sun one of its foci. How the planet moves around the sun? In an elliptical orbit. In an elliptical orbit. With the sun, one of its foci. And second law says that the radius vector drawn from sun to planet seems equal areas in equal intervals of time. The radius vector drawn from sun to planet seems equal areas in equal interval of time. Suppose this is the position of sun, let A, B. The time taken, let a planet reach from A to B be the same as the time taken from C to D. See, if time taken a planet to move from A to B is equal to time taken from C to D, then area OAB is equal to area OCD. This is the second law. That means second law says that the radius vector drawn from sun to planet seems equal areas in equal intervals of time. And third one is third laws of planetary motion. Third laws of planetary motion says that means cube of the radius vector that is proportional to square of the time period. That means cube of the radius vector is drawn. That means cube of the radius vector is proportional to square of the time period. That is r cube proportional to this, or r cube by t square is equal to a constant. Is a constant. These are the three laws about motion of planets by Kepler, or otherwise it is called Kepler's laws of planetary motion. Which are they? First one, that means every planet moves in an elliptical orbit around the sun with one of the foci. Sun with one of its foci. Second one, that means the radius vector form area equals. That means here the A to B time period and here C to D time. If these two are equal, then area also equal. And third one, cube of. That means radius vector is proportional to square of the time period. Now, based on this third law, Newton derived gravitational force, otherwise gravitation. Newton used this third law to calculate force of gravitation. Okay, now see, you want to remember about these three laws of Kepler's. Now, we can go to what is universal law of gravitation. Universal law of gravitation. What is a universal law of gravitation? The statement is that every object in the universe attracts. Every object in the universe attracts every other objects with a force, and that force is proportional to product of their masses, and that force is proportional to product of their masses, and inversely proportional to the square of the distance. Suppose we consider two objects, one with mass capital and another one with mass smaller, and the distance between the distance is measured from the center of the body, and let that distance is d. Now, Newton's universal law of gravitation says every object in the universe attracts every other object with a force, and that force is proportional to product of their mass. Here mass one is capital M and another one is small m. Then their product is m proportional to m and small. And this force inversely proportional to square of the distance, that is 1 by d square. And this force acts along the line joining the centers of the body. This force acts along the line joining the centers of the body. Once again, Newton's universal law of gravitation says every object in the universe attract every other object with their force, and that force is directly proportional to product of their mass and inversely proportional to square of the distance. Here masses capital M and small m, and the distance from the centers of the body, and it is be taken as a small d. So f proportional to 1 by d square. By comparing these two, we get f proportional to m by d square. We can replace this proportionality with the equal sign. We can replace this proportionality with the equal to sign. For that, we want to give a constant. Here that constant is capital G, and remaining quantity is mm by d square. And this G is called gravitational constant. What is called? Gravitational constant. G is called, here the G is the constant of proportionality, and what is called? Gravitational constant. And we can find its unit, see, from this relation to get G is equal to this f and d square comes together, f d square, and this m that goes down. So G is equal to f d square by m. Now we can write the unit of f means force, it is Newton, and d means distance, and its square is here, so meter square, Newton meter square, and m mass, another mass, that is kilogram square. The unit of gravitational constant is Newton meter square per kilogram square. Newton meter square per kilogram square. See, G is equal to f d square by m. The value of G was calculated by Henry Cavendish. Who calculate the value of G? Henry Cavendish, by using torsion pendulum, or say by using a sensitive pendulum, and he got its value as, that means G is equal to 6.673 into 10 raised to minus 11. 6.673 into 10 to the power minus 11. This is the value he got by measuring the value of G. Okay, see here 6. Now we can write a unit also. What is the unit? Newton meter square per kilogram square. Newton meter square per kilogram square. Now once again, Newton's universal law of gravitation. Very important. What is the statement of this one? Every object in the universe attract every other object with a force, and it is directly proportional to product of their masses and inversely proportional to square of the distance, and these force acts along the line joining the centers of the masses. Centers of the masses, that is here distance we took it as D. So here we got a proportionally amount, another distance D square. By combining these two, we got what? Amount by D square. Now this proportionality we changes to equal. We know whenever we change proportionality with proportionality to equal, we want to give a constant, and that constant is called a constant of proportionality. Here that we took as a G, and it is called a gravitational constant. From this, G is equal to F D square by M. That is unit for force in Newton, and distance meter square, and mass. Two masses here, m at kilogram square, and the value of this by the value of this is calculated by Henry Cavendish by using a torsion pendulum, otherwise a very sensitive pendulum, and he got it as 6.673 into 10 to the power minus 11. Now see, here this law is called a universal law. Why this law is called a universal law? Because this law is applicable for bodies of very, very small and bodies of very large. That means bodies can be small or big. This is applicable. And also it is applicable for terrestrial bodies and also celestial bodies. It is applicable for what is terrestrial as well as celestial. Terrestrial as well as celestial. So it is called a universal law. It is also called a inverse square law. It is also called a inverse square law because if the distance between them, suppose if the distance between them is 6 times increased, then the force becomes, see, if the distance D suppose equal to 6 times increased, then the force now becomes its square of D square, that is force become 1 by 36. Force now becomes 1 by 36. Force now reduced to 1 by 36. Now you know the equation which Newton got by using Kepler's third law, and which is that law? F is equal to G capital M small m by d square. By using this, we can solve one numerical problem. See, in our text, it is given in page number 134. The mass of the earth is 6 into 10 raised to 24 kg. And that of moon is 7.4 into 10 raised to 22 kg. If the distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer. Calculate the force exerted by the earth on the moon. G is given as 6.7 into 10 raised to minus 11. Unit we know Newton meter square per kilogram square. Okay. Now, what are the terms here given? First, mass of the earth, that we take as capital. Then, mass of the moon, let it be smaller. Distance between the earth and the moon, that is d. And gravitational constant. Now see, we want to find out force exerted by earth on the moon. See, F is equal to Gmm by d square. That is F is equal to G. 6.67. Here it is given as 6 point approximately 7. So we can take as 6.7 into 10 raised to minus 11 into mass of the earth. How much? 6 into 10 raised to 24 into mass of the moon. 7.4 into 10 raised to 22 divided by. Then d. Here d is given in kilometer, but SI unit of distance is meter. So d is equal to 3.84 into 10 raised to, we want to multiply with 1000. So 10 raised to 5 become 10 raised to 8 because 1000 meter is 1 kilometer. So this much meter. Now we can put this value here. That means 3.84 into 10 raised to 8 the whole square. Now this one more step, 6.7 into 6 into 7.4 into see 24, 22. That means 24 and 22. How much it will come? 24, 22. That is 6, 4. From this minus 11 we can deduct. We can subtract minus 11. 5, 3. That means 10 raised to 35. Here again 3.84 into 10 raised to 8 the whole square. That means this will get us 3.84 into 3.84 into 10 raised to 8 the whole square. We know a raised to m, the whole raised to n means a raised to m into n. That is a raised to m, the whole raised to n is equal to a raised to m into n. By using this relation, we get it 8 into 2. That is 10 raised to, how much will come? 16. Okay, 10 raised to 16 it will come. Now, multiplying this, now we can subtract this 10 raised to 16 from 35, then we get a 90. By solving this whole, we get the value as 2.01 into 10 raised to 20 Newton. This is the force that exerted. That means 2.01 into 10 raised to 20 Newton. You know, these three you want to multiply, and after multiplication, this 2 you want to multiply and divide this with this one, this with this one, and by simplifying again we get 2.01 into 10 raised to 20 Newton is the force exerted by Earth on the moon. Force exerted by Earth on the moon. Okay, because that is centripetal force is keeping. That is centripetal force is the force that keeps a body in its circular path. Here that centripetal force is provided by the gravitational force. Suppose in the same way we can calculate the gravitational force between any two of you. That is force of attraction between any two of you. Suppose how we find it? Let one of you with suppose any one of you with a mass m is equal to 60 kg and another one with a mass 50 kg, and you are sitting at a distance of 1 meter. Now you think even though the force is attraction, why you are not come close to each other? Now we can calculate how much is the force acting in between you. Suppose the force mass among one of you is 60 and another one is with 50 kg. Now by using that means F is equal to G 6.7, just as the value we took from the previous problem. That is 6.7 into 10 raised to minus 11 into one of you with 60, another one is with 50. By the distance between you 1 meter, so 1 square. Now say that is equal to 6.7 into 6 into 5, this 10 raised to minus 11 we can give, into 6 into 5, 30 and 20, 3000. Now we can multiply this 6.7 with the 3000. This 30 we can remove from this, so that the minus becomes 8. Now see that is equal to 3 times 7, 21. 3 times 7 is 21. Balance is how much? 2. 3 times 6, 18, 20. And 1 point into this 3, 0 we removed by replacing this minus 11 to 10 the power minus 8. 10 the power minus 8. See, now actually how much is this value? That means one more minus we can remove by this. That means we want to shift 8 decimal from this. That means 1, 0, 2. Then 6 more. Place 1, 2, 3, 4, 5, 6. This is the force between them. That That means the force between you and your friend is how much? That means 0.1, 2, 3, 4, 5, 6, 2. That much Newton only. That is how weak is this force? See? That means the force acting in between you is how much? That is equal to 0.0000002 Newton only. That means this force is very, very small. Because of that, you are not moving or coming close to each other. This force is very, very small, so that you are not moving close to each other. This is the reason you are not moving close to each other. Now, the question here given, state the universal law of gravitation. State the universal law of gravitation. How you state it? Every object in the universe attract every other object with a force, and that force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them, and that force acts along the line joining the centers of the body. And second question here given, write the formula to find magnitude of gravitational force between the earth and an object on the surface of the earth. See, write the formula to find the magnitude of gravitational force between the earth and an object on the surface of the earth. That formula you want to write. See. Suppose we know this is our earth and its mass we can take as a capital, and this is the center of the earth. Suppose a body is placed here. Now, mass of this body is small. Mass of this body is a small m. Now the distance between the centers of this one, you see, compared to the size of the earth. When we compare the size of the earth, the body on the surface of the earth is very, very small. So the distance between the centers of the body, that means from the center of the earth to this body, is how much it will come? That is actually equal to radius of the earth. That is actually equal to the radius of the earth. Now what we want to find out? Force between these two. That means by Newton's law, F proportional to capital M small m, and F proportional to 1 by r square. By comparing these, we get F is equal to G capital M small m by r square. Here M mass of the earth and small m mass of the body on the surface of the earth, and r radius of the earth. Here why we are not taking this distance, because when we comparing with the radius of the earth, this distance is negligibly or very, very small, so we can take it as a radius itself. This is the force between the body and earth. In the when we discussed about when a stone thrown upward, that stone is actually going up to a certain height, falls to the earth with a very high speed. The force between that stone and the earth, you know, the reason to find Newton. The universal law of gravitation or force of gravitation is when he was sitting in his garden, an apple fell in front of him. He thought why that apple is falling down. Why does it is not going up? From that he moved to the law of gravitation, and here you see the apple got at a very high speed. Even though the force between, that means mutual force is there. Gravitational force is actually mutual force. If that force is mutual, then why does the earth not moving towards the apple? Only apple is falling down. Earth is not moving up. From second law, we know F is equal to ma, or A is equal to F by m. That means acceleration depends on mass. That means for F, its mass is huge or very large. So the acceleration is very small. But for the apple, even though the force between them are equal, but mass of the apple is very, very small compared to the mass of the earth. Because of that, apple is accelerating towards the earth, or a stone is falling towards the earth instead of earth going up. Because of that ratio of mass when we consider from second law, that is a ratio of force to mass, ratio of force to mass when we consider, that means mass of the earth is very high, so its acceleration produced is very small, but mass of the stone or apple is very small, so it is accelerating too much compared to earth. Because of that they are falling down. Now we want to know what is the importance of law of gravitation. That means even though some forces that were not connected, but the law of gravitation provide some valuable information to us. Among that one is why planets move around the sun. That explained based on this, due to the gravitational force. Why moon moves around earth? Why moon moves around earth? That is also due to gravitational force. Then why satellites, that means artificial satellites moves around the earth, or why moon moves around the earth, or the force which bind us to the earth, also we can explain on the basis of this universal law of gravitation. On the universal law of gravitation we can explain these all things, which are things, the force which bind us to the earth. Another one is why moon moves around the earth, why an apple falls to the earth, falls towards the earth, why planets moves around the sun, and also why the tides forming, that means tides due to moon and sun, etc. Also we can explain on the basis of this gravitational force. Okay, now we discussed the terms today. Universal law of gravitation. What is actually universal law of gravitation? Every object in the universe attract every other object with a force, and it is proportional to product of their masses and inversely proportional to square of the distance. Then from Kepler's laws of planetary motion. Kepler's laws of planetary motion says that every planet moves in an elliptical orbit with the sun on a fixed foci. Then second one, what is the area swept by radius vector, that is equal to, for example, that we discussed here. Then cube of that is equal to, that is sun to planet, that is cube of the radius vector is equal to square of the time period, that also we discussed. Then importance of universal law of gravitation. What are the importance of universal law of gravitation that help us to explain about which force binds us to the earth and which force keeps moon moving around the earth, and why, and also it explains why planets moves around the sun. Okay, this with this all we can wind up today's class. Okay.